When distributing power to our buildings, it's essential to follow safe and effective practices. Let's discuss key aspects of your project. Firstly, wire sizing. Using 1/0 American wire gauge aluminum wire from the subpanel to the machine shed is suitable for a load of up to 30 amps per phase. Be sure to use appropriately sized wires for all subcircuits and connections between the subpanels and the distribution panels. Secondly, panel configuration. Installing subpanels at each chicken coop, hog barn, and machine shed is a good approach. Make sure each subpanel has the number of circuits and amperage ratings needed for the loads it will serve. Thirdly, backfeeding. Backfeeding the machine shed panel with a 30 amp breaker is permitted if specific conditions are met. The machine shed panel must be clearly labeled as backfeed. The main panel breaker feeding the circuit must also be a 30 amp breaker. The wires supplying the machine shed panel must be rated for the total load, which in this case is 30 amps. Fourthly, circuit protection. Install the appropriate circuit breakers or fuses at each subpanel and in the main panel to safeguard all circuits against overcurrents and short circuits. Fifthly, grounding. Ensure proper grounding of all electrical components. This includes the panels, enclosures, and all equipment. Proper grounding is crucial for electrical safety. Consider these additional points. It's highly recommended to consult with a licensed electrician to verify your calculations and ensure complete compliance with all relevant electrical codes. Use polyvinyl chloride conduit or other approved methods to protect the wires from physical damage. Think about installing surge protectors at each subpanel to protect against electrical surges which can damage sensitive equipment. Let's dive into more detail. When choosing wire sizes, refer to the National Electrical Code, specifically Table 310.15b16 and other relevant tables. These tables provide ampacity ratings for various wire types and sizes based on factors like insulation type, temperature rating, and installation method. Remember to account for voltage drop over the 800-foot distance. Voltage drop can reduce the efficiency of your equipment and cause it to malfunction. Use a voltage drop calculator to determine the appropriate wire size to minimize voltage drop to an acceptable level, typically no more than 3% for branch circuits and 5% for feeders. When selecting subpanels, consider the number of circuits you'll need in each location. It's always a good idea to have some spare capacity for future expansion. Choose subpanels with appropriate amperage ratings for the anticipated loads. For the chicken coops and hog barn, a small 4 or 6 circuit panel might be sufficient, while the machine shed could benefit from a larger 6 or 8 circuit panel. When backfeeding the machine shed panel, it's absolutely crucial to follow all safety precautions. The back breaker must be securely held in place to prevent accidental disconnections. This can be achieved using a listed breaker hold-down kit. The panel must be clearly labeled to indicate that it is being backfed. This labeling should be visible and easily understood by anyone working on the electrical system. Make sure the back breaker is properly sized to protect the wiring and equipment connected to the panel. Do not exceed the ampacity rating of the wiring. For circuit protection, use circuit breakers or fuses that are appropriately sized for the circuits they protect. Circuit breakers are generally preferred over fuses because they can be reset after a fault, whereas fuses must be replaced. Use ground fault circuit interrupter, or GFCI, protection for all circuits serving outdoor locations and wet areas. GFCI protection can help prevent electrical shock by detecting ground faults and interrupting the circuit. Proper grounding is essential for electrical safety. All metal enclosures, panels, and equipment must be properly grounded to provide a low impedance path for fault current to return to the source. This helps to trip circuit breakers or fuses quickly in the event of a fault, preventing electrical shock and fire hazards. Use a grounding electrode system that complies with the National Electrical Code requirements. This may include a ground rod, ground ring, or connection to a metal water pipe. Bond all metal components together using appropriate grounding conductors. When running wires underground, use direct burial cable or install the wires in conduit. Direct burial cable is designed to be buried directly in the ground without additional protection. Conduit provides additional protection for the wires and makes it easier to replace or upgrade the wiring in the future. Make sure the conduit is buried at the proper depth to protect it from damage. Use weatherproof enclosures and fittings for all outdoor electrical connections. This will protect the connections from moisture, corrosion, and other environmental factors. Inspect all electrical connections regularly to ensure they are tight and secure. Loose connections can cause overheating and electrical hazards. If you are not comfortable working with electricity, it is always best to hire a licensed electrician to do the work for you. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. Always de-energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized before you begin working. Wear appropriate personal protective equipment, such as safety glasses and gloves. Follow all applicable electrical codes and regulations. By following these guidelines, you can safely and effectively distribute power to your outbuildings. Remember, safety is always the top priority. Now let's look more closely at some of the considerations in the project. The American wire gauge, or AUG, is a standardized wire gauge system used predominantly in the United States for the diameters of round, solid, non-ferrous, electrically conducting wire. The larger the AWG number, the smaller the wire diameter. For example, 1 aught AWG is larger than 2 AWG, which is larger than 4 AWG, and so on. The ampacity of a wire is the maximum amount of electric current it can carry continuously without exceeding its temperature rating. The ampacity of a wire depends on several factors, including the wire size, insulation type, ambient temperature, and installation method. The National Electrical Code provides ampacity tables that list the ampacity ratings for various wire types and sizes under different conditions. Aluminum wire has a lower ampacity than copper wire of the same size. This is because aluminum has a higher resistance than copper. When using aluminum wire, it is important to use connectors that are specifically designed for use with aluminum wire. Aluminum connectors are typically made of aluminum or are plated with aluminum to prevent corrosion. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Voltage drop can cause equipment to malfunction or operate inefficiently. The amount of voltage drop depends on the current flowing through the conductor, the length of the conductor, and the resistance of the conductor. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. A subpanel is an electrical panel that is fed from another electrical panel, typically the main panel. Subpanels are used to distribute power to different areas of a building or to specific loads. Subpanels typically have their own main breaker that protects the subpanel and the circuits it feeds. Backfeeding is the practice of supplying power to a panel from a source other than the main panel. Backfeeding is typically done when using a generator or other alternative power source. Backfeeding can be dangerous if not done properly. It is important to follow all safety precautions and to use a listed transfer switch to prevent backfeeding into the utility grid. Circuit breakers are devices that protect electrical circuits from overcurrents. Circuit breakers trip when the current in a circuit exceeds the breaker's rating. Circuit breakers can be reset after they trip. Fuses are also devices that protect electrical circuits from overcurrents. Fuses melt when the current in a circuit exceeds the fuse's rating. Fuses must be replaced after they melt. Grounding is the process of connecting electrical equipment to the earth. Grounding provides a low impedance path for fault current to return to the source, which helps to trip circuit breakers or fuses quickly in the event of a fault. Grounding also helps to prevent electrical shock by providing a path for stray currents to flow to ground. A ground fault circuit interrupter, or GFCI, is a device that protects people from electrical shock. GFCIs detect ground faults and interrupt the circuit, preventing current from flowing through a person's body. GFCIs are required in all wet locations, such as bathrooms, kitchens, and outdoor areas. Polyvinyl chloride, or PVC conduit, is a type of plastic conduit that is used to protect electrical wires. PVC conduit is lightweight, durable, and easy to install. Weatherproof enclosures are enclosures that are designed to protect electrical equipment from the weather. Weatherproof enclosures are typically made of metal or plastic and have a gasketed cover to prevent moisture from entering. Surge protectors are devices that protect electrical equipment from voltage surges. Voltage surges can damage sensitive electronic equipment. Surge protectors divert excess voltage to ground, protecting the equipment from damage. A licensed electrician is a qualified professional who is trained to install and repair electrical systems. Licensed electricians have passed an exam and are required to meet certain continuing education requirements. It is always best to hire a licensed electrician to do electrical work if you are not comfortable working with electricity yourself. Here are some additional safety tips for working with electricity. Always de-energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized before you begin working. Wear appropriate personal protective equipment such as safety glasses and gloves. Follow all applicable electrical codes and regulations. Never work on electrical equipment when you are wet or standing in water. Never overload electrical circuits. Never use extension cords as a permanent wiring solution. Never tamper with electrical equipment. If you have any questions about electrical safety, consult with a licensed electrician. By following these safety tips, you can help prevent electrical accidents. Remember, electricity can be dangerous, so it is important to take all necessary precautions to protect yourself and others. Furthermore, let's expand on aluminum wire. Aluminum wire is a common conductor in electrical systems, particularly for larger gauge wires due to its lighter weight and lower cost compared to copper. However, aluminum has different properties that require specific installation practices. Aluminum expands and contracts more than copper with temperature changes. This can lead to loose connections over time if not properly installed. Use connectors and terminals specifically listed for use with aluminum conductors. These connectors are designed to accommodate the expansion and contraction of aluminum and prevent corrosion. Apply an antioxidant compound to the aluminum conductor before making connections. This compound helps to prevent oxidation, which can increase resistance and lead to overheating. When tightening connections, use a torque wrench to ensure that the connections are properly tightened to the manufacturer's specifications. Over-tightening can damage the conductor or connector, while under-tightening can lead to loose connections. Regularly inspect aluminum wire connections for signs of looseness or corrosion. If you find any problems, retighten the connections or replace the connectors as needed. Now let's discuss conduit in more detail. Conduit is a raceway used to protect electrical conductors from physical damage and environmental factors. There are several types of conduit available, each with its own advantages and disadvantages. Rigid metal conduit, or RMC, is a heavy-duty steel conduit that provides excellent protection for electrical conductors. RMC is typically used in exposed locations where the conduit is subject to physical damage. Intermediate metal conduit, or IMC, is a lighter weight steel conduit that is similar to RMC. IMC is typically used in concealed locations where the conduit is not subject to severe physical damage. Electrical metallic tubing, or EMT, is a thin-walled steel conduit that is easy to bend and install. EMT is typically used in dry, indoor locations. Flexible metal conduit, or FMC, is a flexible conduit that is used to connect electrical equipment that is subject to movement or vibration. Liquid-tight flexible metal conduit, or LFMC, is a flexible conduit that is designed to be watertight. LFMC is typically used in wet locations. PVC conduit is a plastic conduit that is lightweight, durable, and easy to install. PVC conduit is typically used underground or in corrosive environments. When selecting conduit, consider the following factors: the type of environment where the conduit will be installed, the amount of physical protection required, the ease of installation, the cost. Finally, always consult the NEC and local codes for specific requirements related to conduit installation.